Welcome back. Now that we know how to select data from the CSV files, let us go a bit deeper and look at the data types being used by Synapse. As you can see, we haven't defined the data type for any of our columns, and we left that to Synapse to infer. This is perfectly reasonable to start the exploration for your project, but might not be the best approach if you're running repeated queries on the data. I'll show you why that's the case in this lesson. But first, let's see the data types being used by Synapse for our data. We can use this total procedure called sp_describe first result set to identify the data types inferred by Synapse. So let's run that curly to find the data types being used for our columns here. So I'm going to copy the select first because that needs to be fed into the stored procedure. In order to run the stored procedure, you run the command exec and then the stored procedure, which will be sp_describe first results set. And then we need to send that query as a string because the SQL itself has got quotes in there. We need to double quote them so that the quotes are escaped. So I'm just going to add another code that about that is a code, to be honest. Actually, these two statements are not required at all. The field terminator and the row terminator. As we know, the default for a CSV file is a comma and a /end or a new line character. So that's being quoted now. So we've got the select statement that's being fed into this total procedure, and that's going to tell us what data types are being used for our 4 columns. So let's run that statement now. And I missed something. So there is a code here which I haven't escaped, so I'm going to do that as well, and then let's run it again, and that should give us the results. Now, as you can see, Synapse being a bit generous here in terms of allocating the size of the columns, location, IDs being defined as big End, and all of the string columns are being defined. That's about 8,000. We know for a fact that that is too big because we know that the location ID will ran up to 3-digit number and the string columns were only in about 20 to 50 characters long. I think there were no more than that. In order to be sure, let's run the max column length on each of the columns to find out what the real sizes are. Let's copy this select statement here and then I'll put that underneath and I'm going to run the max on each of the columns. Let's do that. So that query should now give us the max length of each of the columns. I'm going to just run that through and we can see the outputs there. As you can see, they are much smaller. Location ID is 3-digit number. That's the maximum length of the location ID. And then the borough is 13 characters, and that is on only 45, and service zone is only 11. Obviously, Synapse trying to use much bigger data types, and there are 2 reasons why you wouldn't want to go with the default sizes from Synapse. Number 1 is a serverless pool, as you know, charge assessed based on the amount of data processed. You wouldn't want Synapse to assume such big sizes for the data types and charge you significantly more than what you should be. So that is the cost aspect of it. And the second one is that the data types do affect the query performance. So you wouldn't want your performance of the queries to suffer as a result of the default data types there. So it is recommended to use the smaller data sizes as possible when you are running queries. I'll show you how to define the data types are. This is a small file so you won't see the fact that much, but I'll demonstrate the bigger file later down the course. Let's copy this select statement and then make the necessary changes to provide the explicit data types. And I'm going to remove the max on the column names and instead I'm going to put a star because I want to see the data from all the columns and the width class goes here after the open row set. So you put width and then open and close brackets and the data type and the column name goes here. You need to provide the exact names of the columns. So we've got location ID, which is only 3 characters or 3 digits, so you can use a small int and the button is 13 characters on its 45 service zone is 11. So what we'll do is we'll keep the borough as 15 zone, that's for 50. And then again service zone is 15 just to future-proof it. So if we get any new data that will still probably fit in there, otherwise we'll have to make some changes. So let's do that. So that's all done. Let's execute the statement and the result should be exactly the same. For some reason, the location is not being populated, and I think that's because I've spelt the location incorrectly. When I say spelt, I just given the wrong case for the ID. The casing does matter on these things because the default collation on the database has got case sensitivity set. You can change that if you wanted to. But at the moment, actually, this case sensitive. That's why it didn't work. So I've changed the location ID to uppercase ID, and that should work. Okay, let me run that through. Yeah, that works out fine now. So you may want to pay closer attention to the column names, especially on this file. The column names are all messed up. As you can see, some of the column names have got a title case, and then this one's got a camel case. So it's got a lowercase with underscore as well. It is slightly weird, but you could get this kind of data in real projects. I'll show you what collation is and how you can change it for the database shortly as well. Finally, let's just make sure that the data types we have specified are the data types being used by Synapse as well. As you know, in order to do that, you can run the stored procedure, describe first result set, and just feed in the code to that and it'll give you the results. So let's do that. And let's execute it now, and it should give us the right data types. So as you can see, we got the location ID, small int, and the other is defined in the with clause. With this change, when you run the SQL statement in the future, Synapse is only going to allocate the right amount of memory to read each of the records. And we're only going to charge you for the right amount of data being processed. It won't allocate unnecessary memory, and also the query will be performant. You can see how much data is being processed by looking at the messages here. So if you go to the messages, you will have a statement here saying total size of data scanned and total size of data moved, and also total face of data return in some cases. You'll also see total sets of metadata being read as well. So in this case, it's just 1 megabytes because that's the minimum amount. But this file is way too small. So if you had a bigger file, you will see the clear differences between those three and this one, which we'll look at later on. So at the moment, we just need to understand that it's best practice to define the data types for the columns so that it is performant as well as cost effective.